Now we are asked to calculate the terminal potential difference of the battery. What does that mean? Terminal potential difference is sometimes called Vcells. It's the potential difference which you would measure if you placed a voltmeter across the terminals of the battery. Notice that there are two other potential differences which fall into the space between the battery's terminals. The EMF, which is 12 volts in this case, and the lost volts, which are 1,6 volts in this case. The EMF is the voltage which the battery puts in. You can measure its value by placing a voltmeter across the terminals of a battery when it's not connected in a circuit, so that no current is flowing through it. When you then connect the battery into a circuit, and therefore current now flows, some of the voltage which the EMF puts in is wasted inside the battery as the current struggles through the battery's internal resistance. The internal resistance converts some of the electrical energy which came from the EMF into heat which leaves the circuit, and that is called lost volts. The voltage which is left over is the terminal potential difference, Vcells. So can you write an equation showing the relationship between EMF, Vcells, and Vlost? Can you see that EMF is the total amount of voltage supplied, from which some is lost inside the cell, Vlost, and the rest is available to the circuit, Vcells. Vcells will equal Vload. So EMF equals Vcells plus Vlost. Or, rearranging to make Vcells the subject of the formula, Vcells equals EMF minus the voltage that is lost due to battery internal resistance. Now you should apply this formula to calculate the terminal potential difference, Vcells, in this particular circuit. The EMF is 12 volts and the lost volts is 1,6 volts. Therefore, Vcells must be 12 minus 1,6 equals 10,4 volts. This picture summarizes the relationship between all these variables. Remember that Vcells will also equal Vload. Vload means the voltage lost across the resistors in the external circuit. So in this case, the terminal potential difference is 10,4 volts.